that back on. Okay, so now we're recording. Okay, so this is our class on Riemann sums. Let me share here and share there. Okay, so this should look like the notes that were posted. So I kind of did a lot of verbiage here. So up to this point, we've done all the derivative stuff, which is all rate of change. Now we're going to be flipping it and doing these classic problems that are typically area under the curve. Let me just turn my pen on. So this is all going to be area under the curve problems. So finding the area, we actually are going to say that the area is between the curve and the x-axis. So first, we always start out, doing the simplest and then see how we're going to do this. So here's our case one. If we say the area under this horizontal line, so I just made it y equals to some constant. So that's a horizontal line where c is some real number. So this example, what if that c was 2? And so this is that line. So this line is really the line segment, y equals 2. We're going to have to restrict the domain. Otherwise, it goes on forever and ever, and you can never get an area. So we're going to look at this. We're restricting the domain to be from, so x greater than or equal to -2 and less than or equal to 2. So we're basically doing this hair-shaped area. So it says, yeah. So can you determine the area of this region? Yes, just using basic geometry. You can say the area is going to be, this is going to be 2, which is the height. This is going to be 4, which is going to be 2 and 2. So the area is just going to be 4 times 2, which is 8, and the units will be square units. So that's all that is. So this was a rectangle. So I was able to use the fact that it's a rectangle and just find the area as length times width. So that's all we did, and we're good. So that's the beginning concept of this Riemann sums. So then we go on and say, okay, can we do another shape that'll be a little bit more interesting? So instead of having it be a horizontal line, y equals 2, let's have it be a line with a slope that's positive. So again, here's your slope. Here's your line. This is y equals 2x. And I'm going to limit it between 1 and 3 inclusive. The other thing that's going to happen, so that I'm going to stop the line here. Because when we get to the domain, the lowest part of the domain, that's where we're going to stop our line. And likewise, the highest part, because we know that this line is going to go forever and ever, but we want to get some kind of answer here. So notice that we're always figuring out the area between the curve and the x-axis. So we're not going below the x-axis. So this says, okay, the shaded region represents the area between the graph and the x-axis. Okay, so when we did the first one, we had just a rectangle. So we really can make this into 2 shapes. So we have one shape that's a triangle and a second shape that's an area, that's a rectangle, and we can get the area of both. So the way we're going to set it up, we're going to take the area of the triangle, which equals the first section, and then add that to the area of the lower rectangle. And that's will be denoted as 2. So to get the first one, we can say, okay, what is this going to be? So let's put some numbers on here. So if I just count, this is 2. So 2, 3, 4, 5, 6. So this is 6. This is 2. That's going to be 4. This will be 2. So from here to here is 2. From here to here is 4. So when you do a triangle, we're going to say the formula is 1/2 base times height. So that's going to be 1/2. The base I said is 2. And the height we said is 4. These twos cancel. So that should be an area of 4 square units for the triangle. Then we're going to do the rectangle. And that's just going to be length times width again. And we didn't do this height yet, so that's 2. This is also 2. So that's just going to be straight up 2 times 2, which will also be 4 square units. So they're going to sum to 8 square units. Okay, so that's just like the geometry of that work for the area under a curve. So that's pretty simple, and it's nice that we can recognize shapes and find the exact area. So we're not even approximating, we're getting the exact area. So now let's bridge and let's write this in terms of calculus. So we can write the expression we just did as being, this is the integration symbol, and these are the endpoints, 1 to 3. Okay, so those are my endpoints. Here's your equation, the 2x, and then you're going to differentiate everything with respect to x. So they always have the dx if you have a variable of x. So that's how we write what's called an integrand. So then it says, since we know the exact answer, we can go ahead and provide it without doing any calculus yet. Because we can see the shapes, the geometric shapes that we can easily measure, we can use the calculus concept of the equation, but yet derive my answer by using geometry. Okay, so that's how we start doing this. So then we say, okay, can we think of another shape? And how is that going to be? So what if is everyone okay with this? So what if instead we have a slightly more complex shape that we don't really have one equation underneath it? Like we could probably figure it out, but this is where you are going to be running things from here to here. And I am seeing I could make a triangle here, right? And a rectangle down below. So I will still be able to get an exact answer. So let's talk about that a little bit. So how am I going to find that? I still, once again, I have nice shapes to work with. So I'm going to say, okay, let's count. So 1, 2, 3, 4, 5, 6. Here is going to be 6 units. That's the base of my rectangle. And then this is going to be 2. So I already know that my rectangle, I'm going to deal with length times width or base times height, whichever you prefer. And that's going to be 2 times 6. So that's going to be 12 square units. And then let's see if we can get the little triangle. The height is 1, and the width down here is going to be 2. So the triangle will be 1/2 base times height. So 1/2, 2 times 1. That's just going to equal 1. It's also going to be in square units. So I know if I add these together, I'm going to have 13 square units of area between the curve and the x-axis. So in terms of this notation, since I don't just have a line that I can write it out, I'm going to just call that function hx. I do have endpoints. Now I have a negative. I'm going to run it from -2 all the way to 4. So these are endpoints that are on the x-axis. Okay, so you've got two endpoints and they both are on the x-axis. Then if we have the function, we're going to have to end it with dx. And because we're able to calculate it exactly, we say that equals 13 and we're good. Okay, so now we're going to come into a situation that's more typical, a calculus situation. And it's going to be an equation like this, which is a parabola, which we use quite often. So now I have an equation. There's my function, and I have endpoints. So just doing that alone, I can say, let's run this from -1 to 2, and I'm going to call that just f of x, and then I'm going to write it as dx. Then if I want to be more precise, have the same exact endpoints, but now let's write it as 1/2 x squared plus 1. I tend to put it in parentheses if it's more than one term, and then you're going to have dx. So this is really a calculus expression. And I know looking at that, because the parabola is curved, I will not be getting a nice clean answer. So you say, okay, based on the other ones, can you determine the area of this region? And you can say no. And why is it more difficult? And because there's no rectangle, there's no triangle, and there are curves. And the curves are what's going to throw me off until I have a method. So can you write the expression? And yes, you can. That's totally fine. So let me just make this bigger again. So that's going to be the integral from 1 to 2 of 1/2 x squared plus 1 dx. Okay, so I know what my equation is, but I have no way to answer it yet. So thus Riemann sums. So let's take this exact same equation. And so what we're going to do is we're going to start dividing the region under the curve into rectangles. And so we're going to make an approximation. And depending on how many rectangles you have, the higher number of rectangles will give you the best approximation. But we're going to start out with just 3 rectangles. So it says one method is to divide the region into rectangles, and we'll do that. Since the region starts at x equals 1 and ends at 2, let's use 3 rectangles because they come very naturally. So here, start here. Then I have, it will be a rectangle in a second right there. Then I have another one here and another one here. So that's going to give me 3 shapes. They're not currently rectangles. So then we get to build a table. So that's going to be the first thing we're going to do. So if x is -1, we're going to say that this value right here is 1.5. So that's going to be 1.5. That's how I'm getting that table. If x is 0, I can see very nicely that that is a 1. So that's a good number. If x, so this is 0, this is 1. If x is 1, I'm going to say that that once again is 1.5. And if x is 2, this is going to be 3 right here. So now I have some ideas. So we're going to do this 2 ways. And I think I have them done that way. Okay, so we're going to draw a vertical angle. So I have I'm going to do my 3 rectangles again. I'm going to come and do it 2 ways. So initially they talk about lower Riemann sum and upper Riemann sum. But I'm really going to stress them as being left Riemann sum and right Riemann sum, because lower tends to indicate that the value is less. So we're going to do it this way. So I'm going to do, this is going to be left Riemann sums. And so what I'm going to do is I'm going to start on the furthest point left. And I'm going to go straight across, and that's now a rectangle. So I have this one little rectangle right here. So what I did was I touched the curve and then went straight across. Hit the next vertical section and go straight down. Okay, then you're gonna go back up. So I was at -1, that took me to 0. Now I'm gonna go up 0. Because I hit the curve right there, I'm gonna draw across right now, right here. That's gonna be at 1. Then I'm gonna go up again. So I'm coming up here. I hit the curve and I go here and I stop there. So just looking at this, what I'm seeing is that I'm going to have an underestimate here, right? Because that should go up higher, an underestimate here, and an overestimate here. So that's kind of what I'm seeing right now. So let's figure out how I'm going to do the math of this. So neat things, if you do your table like I just did my table, you're going to have 3 rectangles. Here's what you're going to do. You're going to use these values here on this side. So what I know is to get the area of this first rectangle, the height is going to be 1.5, right? 1.5. So this height is 1.5. All my widths will be exactly the same. They will be 1. So that first rectangle will be 1.5 times 1. This next rectangle starts at 0 and goes to 1. And when I go up, this is going to be 1 right here, and that's going to be 1 right there. Then my third rectangle, so this would be 1, this is 2, and this is 3. The third rectangle is going to hit a height also of 1.5 and be 1 across. So you're going to figure out every single area of those rectangles. So I'm just going to do it right here. So to get area of rectangle 1, I'm going to say 1.5 times 1, and that's going to equal 1.5. The area of rectangle 2 is going to be 1 times 1, and that's going to equal 1.0. The area of 3 is going to be 1.5 again times 1, so that equals 1.5. When I add these all together, I'm going to get 4.0 square units. Okay, that is the left Riemann sum. Okay, so we're looking at this. It looks like this is going to be too low because I see that I've underestimated it 2 times. I overestimated it 1 time, but that last place over here where I'm underestimating it, that exceeds this. So therefore, it's going to be too low an estimate. But I have an estimate at least. So that's the left Riemann sum, which probably is going to end up being the lower one. But I don't particularly care about that notation. I want to know that I did it from the left. That's how I get this answer. The lower or higher comes after you actually calculate it. So I think it's going to be the lower one, but let's see. Okay, so that was going from the left. That means I went to the furthest left and I started going up to the curve from there, as opposed to the right Riemann sums. And again, this looks like it's going to be an overestimate, so we'll see. So if I go to the right Riemann sums, I can do the following. I can go all the way to the right and go across here. Okay, so that's my first. So that it's either the first or the third. I'm going to say it's the third right now, and I'll number them in a second. then go up and I hit here, and I'm gonna go across. Then go up and I hit here and I go across. So let's still say we're gonna count from the left. 1, 2, and 3. So then figure out your heights. We know that every single width is 1. So these are all 1s. It's the heights. So look at what we need. The height is a Y measurement. So just look what happened here. Do you see that these guys were my heights? And that's where I get them. Okay, so now my new heights are going to be these. So I have an overlap, but then I pick up the 3 at the end and I lose the 1 at the 1.5 in the front. So let's make sure that that actually works out by looking at our picture. So when I look at that, I'm seeing my height when I went up was 1. So this is 1 times 1. So it's going to be a 1 square unit. When I hit here and I went up and across, this was 1.5. So this is 1.5. So 1.5 times 1 will be 1.5. This last one, when I went up, I really went up. So I went 1, 2, 3. So this side is going to be 3 by 1. So are those the same ones I just recognized? And yes, the 1, the 1.5, and the 3. So the red over here was the left Riemann sum, and the green I just did was here, and that was the right Riemann sum. So let's finish doing the math here for the right. So this is the right Riemann sum. And what I did to figure out my areas, so the area of 1 was going to be 1 times 1, so that equals 1 square unit. The area of the second one is going to be 1 times 1.5, so that's 1.5 square units. And then area 3 is going to be 1 times 3, which is 3 square units. And so when I sum them, I get 5.5 square units. So now I really can say that this is my upper Riemann sum because it's a bigger number, and that this is my lower Riemann sum because it's a smaller number. So then they ask us about this here. So I said the upper is 5.5, 5.5 square units. So it says to better approximate, you can take the average of the upper and the lower. So if you take the average, you're going to get 5.5 plus the 4. So that's 9.5. So I'm going to get what, 5.75? Am I doing that correct? It's been a long day.
4.75.
Thank you. Say that again.
4.75.
4.75, yep. Knew I had 7.5 in there. So this is 4.75. So that's the approximation. That's why we have this as approximate, and these are still square units. I haven't said what my units are, but I know that they're going to be square units. See? Yeah. Okay, so then what else can we do with this? So let me just see if I have that 5.5. Yeah, so we're good. So now can't I Well, so I'm gonna highlight this because now I have some calculus here. I'm still using algebraic methods there, but at least I'm getting there. You know, I am almost using calculus, but I'm using a theory that's kind of cool. And so you can see the more rectangles I have, the thinner they are, the better approximation I will have. So we're gonna stick with the left and right. And then if we want to say which is higher and which is lower, we can, but it's all about building them correctly. So I said, okay, let's try another one. So we're gonna now switch over. Instead of saying lower and upper, we're gonna always say left and right. So here we have this situation. So find the left and right Riemann sums. This time, we're gonna use 4 rectangles. So you can see what's gonna happen to get my rectangle lengths. This is what you do. You take your 2 minus the lower, the 0, because I'm looking at my A and my B. And then I said I wanted to have 4 rectangles. So now I know that the length, or I guess the width, this way, is going to always be 1/2. So that means that I'm going to have to put the 1/2 mark here and then go up to the top and figure that out. So the nice thing is I do have an equation. So I can write this out in calculus terms. And I can say I'm going to go from 0 to 2. And I'm going to put my 4 minus x squared in here. And I'm going to say dx. And because I'm using Riemann sums, I know I'm going to get an approximation. But that's what I'm going to do. Okay, so now what I want to do is I want to draw in these rectangles. And then I'm also going to create my table. So we'll do that. So let me just see. I should be able to get fairly straight lines. Okay, that looks okay. And then I'm just going to darken this one. And then I'm going to go up and hit here as well. And then I'm going to go across. Am I going to go across? No, I'm not. So let me not go across yet, because I want to make sure that we're okay with the increments, and let's figure them out. This is going to be 0.5. That's going to be 1.0. This is 1.5, and this is 2.0. Then according to here, so this is 1, 2, 3, 4. And then I can use my x values to get an exact figure for my y values as needed. So with that in mind, now that I know what it's going to look like, I'm going to come down here and I'm going to fill in this chart. So if I use an x value of 0.5 and I put that in my calculator, I'm going to end up getting a y value of 3.75. So that's going to kind of be right here. So this is 3.75. Then if I use 1.5 and I put it back in this formula, I will get a y value of 1.75. And then I had given you all the other values in there. So then what I know is that every width, so all of my widths will always be 0.5. And if I'm going to do it from the left, I'm going to use my y values that are here. So if I'm going from the left, I'm going to use these y values. So that's going to be for left Riemann sum. If on the other hand, I go from the right, I'm going to end up using these y values. And that will be for right Riemann sum. So then that, what I can do is we can I'll draw in the left Riemann sum. So if I drew in the left Riemann sum, I'm going to start from the left, which means this. So I'm going to do that in red. I'm gonna go all the way up. Do you see how I hit 4 right there? So I'm gonna go over to here, and then once I hit the next vertical section, that will be my tower or my rectangle that I'm gonna be using. Then when you want to do the next point, you're going to go up to 0.5 and you're going to hit the curve and you're going to hit at 3.75 and go straight across until you get the next vertical section. So now you have that. And if I shade it this way, you'll be able to see where one starts and the other one ends. Okay, so now I have one rectangle, I have 2 rectangles, and they're all from the left side. Then I go up the left again, I hit the curve at 3, I go across 1/2, and I come down here. And I'm going this way. And then I know I needed 4 rectangles, so I've got one more to do. So I'm going to come up from 1.5, hit the curve right here, and go across. And that's going to be at 1.75 and come down. So then we're going to go this way with that. And that's rectangle 3 and rectangle 4. Okay, so in terms of left Riemann sums, maybe I'll do them in red since I did everything in red here. So I know that my widths are all 0.5. So I can say 0.5, take your first y times 4 plus 0.5 times 3.75 plus 0.5 times 3 plus 0.5 times 1.75. Okay, so I think I added that up. I got 5.5 square units. So that's from the left. So then I'm not going to draw in the right because it'll get too messy, but I'll change it to green. I know they're all going to be 0.5 again. Start with the second y value, which is the 3.75, plus 0.5 times 3, plus 0.5 times 1.75. Now you're going to pick up the last one, plus 0.5 times 0. Do you see why that's going to be 0? If you're going from the right, that's a 0 right there. If you go across, it's going to be right here. So that's your first rectangle. And actually, I can do this. Your second rectangle will be right here. Your third rectangle will be right here. And your fourth rectangle will be right here. So here's your second one from the right here. Here's your third one from the right. And here is your fourth one from the right. Oop, I went up too high. Hold on 1 sec. To get rid of those, stop there. And then that one did go up. So that's going to continue this way. So then let's do the summation for that. When I did the green, I got 4.25. So it looks like the right Riemann sum is the lower and the left Riemann sum is the upper in terms of the value in square units. Yeah. So then you can go ahead and average those, because if you're going to give an approximation, you want to have the average. So that's going to be approximately 4.625, because I took 5.5 plus the 4.25, and then I took the average of those. And these are square units. Okay, so
I
some
got 4.875.
oh, that could be. So I didn't redo with my calculator. And you got 4.875
Yeah.
for the average?
Yes.
Did you have the same two numbers I have?
Yeah. Yeah. 5.5 plus 4.25 divided by 2.
4.25, yep, and then divided by 2. Yep, I agree.
Mhm.
Thank you for checking
Mhm.
that. And so this ends up being 4.875. Okay, good. So you can see it's a pretty good approximation. To make it better, you would make smaller rectangles. You can also do other shapes, like people do trapezoids, you do all kinds of silly things. But the whole idea is you're not using a calculus technique yet, but you're kind of seeing why you want to develop one, because we're not getting the exact answer. So then I thought what we can do, I did some more problems here that you can work together. So let's do that. So I said, use the average of left Riemann sum and right Riemann sum, approximate the area under the curve of these functions given by this. So I don't have a function, so you're just going to call it, H or G or whatever you want to call it. If you're going to use 3 rectangles, you're going to have 4 blocks, 4 columns. If you're going to use 4 rectangles, you'll have 5. So that means, remember, you're always grabbing the y's. So if you're going to do left Riemann sum, you're going to go here up to here, and your width will always be 1. And then to do right Riemann sum, you're going to instead go here to here. Okay, so why don't you go ahead? Let's try to get one done. And then we'll talk about that, make sure we're getting the same answers. I'll redo my math because I think I probably want to do that. And then we'll get all 4 of these done and make sure that everyone's comfortable with this. So I can do the famous, can I stop sharing? Are you okay with what you have? Okay, so then I will do a breakout room. Oh, let's just use one. So I'm going to say create. I'm going to redo some of my work. So go ahead. Why don't we try to do 1 and 2, and then I'll hop in and see how we're doing. Okay. Okay. So go ahead, join the room, and then I'll do my math. You can do your math, and then we can compare. Okay, all right, so let me go back to sharing my screen so I can show you how you're gonna set this up. Okay, so what I did was I drew my rectangles. So if I'm gonna use 3 rectangles, I need an XY box and I'm gonna need 4 other boxes. And so what you can do then, you know you're gonna go from 0 to 3. If I'm using 3 rectangles, I'm going up by 1. So 0, 1, 2, 3. Then you can take this equation right here, and you can put that in your calculator in the y1 equals, and then you can go to the table and get these values for y, or you can do it by hand. So either way works. If you have a graphing calculator, you can go into y1 and put in 16 minus x squared, and then you would go to second table, and then you could find the y values that go along with the x, or do it by hand. So that's the setup. And then when I did the natural log, I definitely put it in my calculator, and I need 4 rectangles, so I made 5 boxes, including the XY, and I rounded everything to 2 decimal places. So I got values that way. So now you can start doing the next 2. So we can I'll do them, you can do them, and we can just compare as we go, see what we get. Oh, the other thing I did was I went ahead and drew it out so I can see what it looks like. So let me not do it like that. So for the first shape, I am on the downward side of a parabola because it's an upside down parabola. So this is where my 16 is, and then I'm going to go like this. So I'm getting the area under there. And then I'm having, this would be 0, 1, 2, 3. And then I can do my rectangles from there. Okay, so that's number 3. And that was y equals 16 minus x squared. And then the setup for number 4 is going to look like this. So it's a natural log function. So what's going to happen is this is going to start about here and then go through like that. So it's going to kind of look like that. And so you're going to have, this is going to be 1, then you're going to have 2, 3, 4, 5. You can see the numbers are all pretty close. But that's what it would look like. So then you can do it without even drawing it, but sometimes it's nice to know what's going on. So now I won't say anything, I'll just do my calculations. So I'm going to get rid of this here, and I'll do my calculations there. Oh, and did you see also, since you know the base is always going to be the same, if you're going to do left Riemann sums, and you know your base is always 1, you can say 1 times, and then it's going to be the sum of 16, 16 plus 15 plus 12. Instead of doing all the multiplication, you can do it that way. Okay, which you probably figured out, but it's a nice little shortcut. Once you see the pattern, then you can do that. And then the right Riemann sum, you're not going to start at 16, you're going to start at 15 and go like that. So then I'll do my math. I think I got. So 16. So am I matching you? I made any math errors here?
Yep, matching me.
Great. Okay, so then you can write it out. So what we can do is you can say, okay, in terms of the calculus, I can write my integrand symbol. And my endpoints are 0 to 3. My equation is 16 minus x squared. And then I have to have my dx. And I'm going to approximately equal the average 43 plus 34 divided by 2. So I'm approximately equaling 38.5. And then for the next one, you can do the same thing. So I have the equation. My endpoints are 1 to 5. This is natural log of x. And this has to go in parens, and then I can put the whole thing in parens, and then I can say dx. And I have 3.18 plus 4.79 divided by 2. And that gives me roughly 3.99 if you round to the nearest hundredth. So does that seem reasonable? So that's the whole thing. So have you all seen Riemann sums before? Back at some point. So what do you think? Catlin, does it make sense? I know Sarah's seen them. Bruna, you
Yeah.
right?
Yeah, I'm doing actually really okay with this.
Okay, good. Yeah, it's kind of fun. It's something the kids could probably like to do because you can make as many rectangles as you want. And you can cut them smaller. And then you can see, okay, what happens if I have more rectangles? You know, they may reason it out, but you can clearly see that you'll get a better approximation. But how much better? How much effort is it worth to make a lot of little ones?
Yeah.
So that's the whole thing. This is our bridge to calculus. So Poonan, I wanted to mention one thing to you about concavity. So when you think about concavity, if your shape looks like this, think about making a face, and that is concave down because you're sad. Okay, so if you have like a shape like this would be about the inflection point. So that means all of this is concave down and all of this is concave up. I think you had it switched when you first looked at it. Does that make sense? And then Catlin, I didn't look at yours yet, so I'll make comments on yours as well.
Mhm.
But so otherwise, I think we're good. So any questions about this? So they'll tell you how many boxes you're going to use. They'll probably tell you to compare a left Riemann sums with right Riemann sums. They might say to identify which one is lower, given the answers that you're getting. So for example, this one is the lower, this one is the upper. And then this is the upper and this is the lower, so they switched. Depends on your shape of your curve, which one's going to be upper or lower. And then this is the notation that they want. If they don't give you a function, then you would just indicate, say if you want a generic, that's your endpoints generically, and then you can have h to the x dx, and then you are going to equal some constant k. So that's the generic equation that you would set up if you want to express your answer to Riemann sums. Okay, and that's all there is to it. So sometimes you have shapes that you can naturally get the area for. If you have that kind of shape, you would not do Riemann sums for this because you'll get a perfect approximation. It'll be an exact answer. So there's no need to do it. But the second you have curves, you've got to do the Riemann sums method to get the area under the curve approximation. Okay, so that's all I have for you. So I will post the exam at 5:30. Any
Okay.
problems, just contact me. I will do a video for the next lesson. And I'll post all the accoutrements that go with that on the different places I can post them. And if you have any questions about that, let me know. And then Catlin, I'll do your paper. Know that, or your
Problems.
problem set, thank you. Long day. So then the other thing is, I will,
Stupid back
what
for
else?
16 minutes.
I'll grade pretty quickly, and I'll post the grade just like I do for everything else. So that'll be up the way it normally is.
Some people work same time. They're not waiting a time.
All I can say.
You're getting the TV on right when I stop.
Oh my goodness, what's going on?
You know?
Why this thing is not charging, Rick?
So anyway, that's all I have. If you think of anything, shoot me a message and I'll get back to you. But have a wonderful Thanksgiving, and then I'll see you. And then all of a sudden, this course is really coming to a screeching end.
Yes.
So it goes super fast. So I hope you got something out of this. I hope you think this is kind of fun to refresh and you have some new ideas for what you could do. If you want to have like a problem day that didn't necessarily follow your curriculum, but can throw this stuff in just for mixing it up, that would be great. And then, so then we have one class after Thanksgiving. And then we'll do more integration with that. I'll make sure you have no questions about the other stuff. You could do one page of that problem set I posted tonight, because one side of it is rim and sum problem, but that's all you can really do. Then we'll have the test, the last regular class day, the last Tuesday. So we're good. So all the dates should be correct now, God willing. I think it's all good. But so that's what we have. So I will be in touch, and I'll have the video up, and enjoy that, and have a wonderful Thanksgiving, and I'll see you when we all get back.
All right, thank you. You do the
Thank you.
same.
You're welcome. Thank
Dr.
you.
Riley, I have a question.
Yes.
Okay, it's related to me, not
Oh,
the
yeah,
first
okay.
question. Yeah. So I did email Donna, but I didn't get a reply from her. Do you think it's all good?
I think it's all good, but I'm not sure, because no one responded to me either to say, oh, I see you have 3 students and you only put down 2. Is there a problem? So I would maybe send another one, just take the exact same one and send it more recently.
Okay, because that's what I was like. Usually she responds, she did not. So I thought, I don't know. On my student portal, it does show that I'm registered. So I'm not sure. Well,